Section 4.6, Graphs of Cotangent Functions. We're going to take a look at cotangent functions as the reciprocal of tangent functions. So we're not going to do the t-chart. We're going to look at our graph below, and this is the tangent function currently. Alright, so cotangent is the inverse of that, or the reciprocal of that. So if you look at the first point at negative pi over 4 and negative 1, the output is negative 1. So it's the reciprocal of negative 1, which is still negative 1. Okay? The next point is at 0. Well, the reciprocal of 0 is undefined. So now our vertical asymptote has moved to the y-axis. At pi over 4 and 1, the reciprocal of 1 is still 1. But then now your vertical asymptotes, where they were undefined, the reciprocal of undefined, or 1 over 0, is now 0. So these values right here are no longer vertical asymptotes anymore. Okay? These are now points of 0. Okay? And so you can see here at negative 1 it stays, that's the reciprocal. And at 1 it stays. But then when tangent was 0, cotangent will be undefined. And then we have, once again, the reciprocal of 1 is 1. At the old vertical asymptote, it is now gone, and that will represent 0. So you can kind of see what we have here, and if we keep going, get one more period in there. This now represents your cotangent graph. So cotangent and tangent obviously are very similar. Tangent's opposite over adjacent, and cotangent's adjacent over opposite. So the vertical asymptotes has shifted. And also look at your graph is now decreasing instead of increasing. So this represents your cotangent graph now, not tangent. And pay attention to the similarities and the differences between tangent and cotangent. Once again, this one is decreasing, and now, because of where the vertical asymptotes for tangent are, they have now shifted over because of the reciprocal of 0 is now undefined, and where the vertical asymptotes, they now become 0. So now let's go through and kind of identify a couple characteristics of cotangent. So the domain will be x such that x cannot equal, and where's that first vertical asymptote? At pi. So x cannot equal pi, and we're going to do n times pi, and you can see that that occurs every integer of pi. So n such that, or x such that x cannot equal n times pi, where n is an integer. Alright, the range stays the same, it's all real numbers. The period, same as tangent, is only pi. It only takes pi units to repeat itself. Cotangent is an odd function. So we have cotangent of negative x is equal to negative cotangent of x. The y-intercept on this one is none because there's a vertical asymptote there. And then the zeros on the graph, you can see we got pi over 4, so this would be pi over 2. And then you have 3 pi over 2, 4 pi over 2, this would be 5 pi over 2. And then 6 pi over 2 would be 3 pi over 2. So you can see, and also in this direction, we got negative pi over 2. So we'll just kind of list these out. So negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and they just kind of keep going from there. Your vertical asymptotes, kind of the same thing in terms of your domain. That's where those restrictions are. So x is going to be equal to n pi, where n is an integer. So once again, reflecting off of what we had for the domain as well. So those are the characteristics of the cotangent function. All right, once again, there's no amplitude of a cotangent, but that a is that vertical stretch, so we still need it. The period is still pi divided by b. Your interval still is the period divided by 4. And your asymptotes are the beginning of the end of the period, but there has been a shift in terms of cotangent and tangent. Your x-intercept is still in the middle of the asymptotes. When a is greater than 0, now the graph is decreasing. When a is less than 0, now the graph is increasing. So pay attention to that, and once again, the difference between tangent and cotangent. So that really covers all the new part of cotangent. Now I'm just going to do a couple examples of cotangent. So once again, the amplitude is none, but I'm still going to write the a value here is 3/4. The period is pi divided by b, which is 2 pi, so that's 1/2. And then if you take 1/4 of 1/2, that's 1/8. All right, and then there is no reflection. We do have it shifting down 2 units, and there is no horizontal shift as well here. You don't see an x minus a quantity. So let's go ahead and split up our period into eighths. So 1/8, 2/8, 3/8, and then 4/8 is 1/2. And then we also will go the other way, negative 1/8, negative 2/8, negative 3/8, and negative 4/8. Alright, also label the y-axis 1 and negative 1. And actually I'm going to change that because it's 3/4, so, well, we're also going to have to shift. So we'll just leave it. We'll go with 1, 2, negative 1, negative 2, and then we'll approximate the 3/4. Okay, so I think we have everything that we need. We need to shift down 2 units. So we'll take the graph and shift down 2 units. So that's kind of our new x-axis, the new middle there. We now need to graph in our asymptotes. So because we are doing cotangent, remember your asymptotes start on, and there's no horizontal shift, so the asymptotes start on the y-axis, and then every period you have another one. So I'm going to go one on the positive, one on the negative. With cotangent, we remember the middle is the x-intercept. And then remember, we are decreasing because the a value is greater than 0. It's our traditional cotangent. We're not doing a reflection. So we need to do 3/4, and so this is where I'll kind of approximate the 3/4. So we'll go 3/4 here and here, and then same thing on the other side. That a value is 3/4, and each of my boxes is 1 unit. So then this represents your cotangent graph. So once again, very similar to tangent. You just got to pay attention to where your vertical asymptotes are, and then whether it's a reflection and how it's either increasing or decreasing. Alright, on this last example here, it looks like we will have a horizontal shift, so we will need to rewrite the equation so that the 1/2 is factored out. So when we factor out, remember we can work backwards by dividing, and so pi over 2 divided by 1/2 is just pi. So that's our new equation with our phase shift on there. So the amplitude is none, the a value is 1, the period is pi divided by 1/2, or pi times 2/1. and then the intervals would be into fourths, so that 2 pi divided by 4 is pi over 2. There is no reflection here, there's no x or no negative a value. Vertical translation, we're not shifting up or down, so there is no vertical translation as well. And then the horizontal shift, it's not pi over 2, you have to factor it out, so it's going to be pi units to the right. Okay, so now when we go to graph this, we do what we always do, is we mark off our interval and our period. So 2 pi, the interval is pi over 2, and mark each interval, pi over 2, pi, 3 pi over 2. Also, we're going to go to the left, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We'll mark our y-axis as 1 and 2, and negative 1 and negative 2. And so now, with that horizontal shift to the right, I'm going to draw on that dotted line, not necessarily indicating a vertical asymptote. This just kind of represents that new y-axis, so this is the shift pi units. Now, when we go back and look at a cotangent graph, the parent function, remember, the vertical asymptote occurs on that y-axis. So when you go to graph and you do your shift, then also your vertical asymptote for cotangent falls on that vertical, or falls on that shift. Now that's not true for tangent, so be aware of the difference between cotangent and tangent. And then now every period we have another vertical asymptote. And we have cotangent, so the x-intercept falls in the middle. Now we didn't shift up or down, so it stays there. And then it will be decreasing. So at negative pi over 2 we need it at 1, and then at pi over 2 we need it at negative 1, so the cotangent graph will be decreasing. And so there you go. There's another example of a cotangent with a phase shift on this one. Once again, pay attention to the similarities between cotangent and tangent, where the vertical asymptote should be, and whether it's increasing or decreasing. And this last slide is just showing you the difference between tangent and cotangent. So this is tangent of x and cotangent of x, where the vertical asymptotes are. So your vertical asymptotes on tangent are to the left and to the right of the y-intercept, whereas cotangent, it falls on the y-intercept and then every period after.